And now we will have our first presentation, which is presented by Mr. Engineer Mahdi Nozarian. Mr. Nozarian is a PhD student working on his PhD dissertation on the topic of smart cities energy system. Mr. Nozarian, please join us.
Thank you.
Yes, you show me to ready.
Hi everyone, good morning. I'm very happy to present this keynote at the IEEE Smart City Week 2022 program, and I'm grateful to organizers, in particular to Dr. Freydunian. Today I'm going to present the keynote to Smart City Energy Infrastructure as a system of systems, including Energy Hub. In this presentation, after introducing system of systems and its characteristics and applications on Energy Hub, I will describe the Smart City Energy Infrastructure as a macro energy hub, including micro energy hub. And then I'm going to describe Smart City Energy Infrastructure as a system of systems. And finally, I introduced a modeling framework and a real case study for Smart City Energy System of Systems. Let me start with some general concept on system of system engineering. Increasing complexity and interconnectedness of systems have attracted interest from researchers in what has known as system of system engineering. System of system engineering is an opportunity to describe and characterize the complex systems of the 21st century. There are numerous definitions of system of system, SoS. However, system of system can be defined as larger scale integrated systems that are independently operable but are networked together for a common goal, providing unique capabilities and services that the constituent systems, CSS, cannot accomplish on their own is a fundamental issue in a system of systems. Mayer 1998 postulated 5 key characteristics, not criteria, of a system of systems include managerial independence, operational independence, geographic distribution, evolutionary development, and emergent behavior. Managerial and operational independence are two principal distinguishing characteristics for applying the term system of systems. A system that does not exhibit these two principal characteristics is not considered as a system of systems, regardless complexity and geographic distribution of its components. System of system engineering, while still being investigated predominantly in the defense sector, is also seeing application in such fields. Political systems, supply chain, design of the internet, software integration, national aid, and the like. Modeling and description of national infrastructure is one of the other such application fields of the system of systems. National infrastructure system of systems sectors that were introduced as constituent systems can be viewed similarly in cities or urban areas. Accordingly, it can be said that in the smart city, several distributed autonomous constituent systems integrated and interacted toward providing new functionalities and optimization of the efficiency of the services, resulting in a smart city system of system framework. Smart city system of system consists of heterogeneous systems developed with different technologies and data formats and owned by distinct organizations. In other words, the smart city involves a public-private, heterogeneous, independent constituent system across different domains: smart energy, smart crisis management, smart teaching, smart infrastructure, smart governance, smart economy, smart environment, smart health, and like. The main processes that benefit from constituent systems integration in a smart city energy system of system include management, planning, and operation. From a different point of view, these autonomous constituent system across different domains similarly can be identified as a system of systems. A good example are the transportation, healthcare, and energy. That's all I have to say about system of system definition, characteristic, and application. It's not that the energy constituent system in a smart city system of systems itself can be identified as a system of system. Leads me to the next point, which is energy hub. Energy hubs, as the prospect of future energy systems, are efficient and reliable framework for generation, conversion, storage, and consumption of energy in a multi-carrier energy system. A significant point is that the energy hubs based on the consumption sector can be divided into types that are named micro energy hub. It is important because the integration of micro energy hub create a concept called macro energy hub, in which a set of energy hubs can be controlled and programmed coordinatedly in a city area. To put it more simply, existing urban facilities in cities can be considered as micro energy hubs. And a city itself can be regarded as a macro energy hub, incorporating its micro energy hubs. As you are all aware, one of the most important advantage of the energy hubs is the utilization of advanced efficient resources and storage technologies that result in effective management of intermittent renewable energy resources and facilitating their integration. Therefore, if cities planned and operated based on a macro energy hub involving micro energy hubs framework, it will be possible to enable cities to meet their sustainable development goals with respect to the energy, and in popular terms, to become a smart city. A smart city is a healthy, energy efficient city that uses renewable energy resources and as much as possible, and is a pioneer in the development of advanced smart technologies. In the other word, the micro-energy hubs are the same constituent systems in smart city energy system of systems that pool their capabilities together to create a new, more functional and reliable system. Accordingly, smart city energy infrastructure is a multi-carrier energy system that provides various types of energy to autonomous consumption from the autonomous distributed generation controlled by local constituent systems. The collaboration in smart city energy system of systems can be possible through the existing information, electricity and natural gas and other urban infrastructure. Let me go back to what I said earlier about Mayer's principal characteristics description. In Mayer's principal characteristics for smart city energy system of system and in operational and managerial independence description, it should be noted that these micro-energy hubs can be operated and managed in independent local mode or as a collection of dedicated systems that pool their resources and capabilities together to create a new system that offer more functionality and performance that named macro-energy hub system of system. These micro-energy hubs can build or develop evolutionary and dynamically due to the equipment lifetime and electrical and heat demand grows over time, which can satisfy evolutionary development characteristics. This principle that these micro-energy hubs, according to their owner location, have been developed in different or distributed areas in urban, is satisfied the geographic distribution characteristics. But emergent behavior should be studied in the main processes that benefit from constituent systems integration in the smart city energy system of systems that are planning, operation, and management. Emerge has its roots in the late 16th century in Latin. Emerge from E variant of X, outwards plus merge to deep meaning, become noun to come to light. The definition implicitly acknowledges that something is added to the existing knowledge that was not known before when emergence happens. These behaviors are emergent properties of the entire system of systems and cannot be localized to any constituent systems, and the principal purposes of the system of systems are fulfilled by these behaviors. Emergent behaviors are often considered negative because they are not a function of the design. However, can also be serendipities and produce unexpected positive results. In this proposed project framework, the micro-energy hubs in the smart city energy infrastructure are designed and planned according to the importance of their demand. These micro-energy hubs can be interconnected through the existing urban power and natural gas distribution grids. This framework seeks to determine the multiple energy generation, conversion, and storage system capacity and placement in the smart city, considering reliability and economic criteria that can be affected by emergent behavior. Usually, a centralized optimization problem is solved to find the optimal planning point of the energy system. The goal could be to maximize the overall benefit of the system while limiting the constraints. However, as both macro energy hub and micro energy hub systems might be independent systems in the smart city energy infrastructure, such a centralized optimization model is no longer an appropriate approach to smart city energy system or system planning. To solve the planning optimization problem of each microenergy hub constituent systems and optimally operate the entire system of system-based smart city energy infrastructure, a decentralized decision-making framework is required. The study case is that will district in the city of Baden, Switzerland, which contain critical industrial, commercial, residential, and agricultural areas, as shown in figure. There are numerous, there is a list for reading on this topic, and thank you very much for your interest and attention. If anyone likes more information and asks a question, please feel free to contact me. Thank you very much.